Welcome back to Botronix Labs. In this module, we're taking your robotic arm project to the next level by adding recording and playback functionality. If you haven't completed Module 9 yet, please check it out first. Most of the hardware setup and joystick control logic are the same, and we'll be building directly on top of that foundation. Before we dive in, let's take a moment to appreciate our 3D printed controller enclosure. This design is by Tokyo_bird, a talented creator on Thingiverse. It keeps your joysticks and buttons organized and makes the whole project much more ergonomic and fun to use. By the end of this module, you'll know how to record servo positions manually using joystick control. Use a 2-button mechanism for flexible one-handed operation and playback. Improve the precision of your robotic movements, and apply button state detection and smooth servo movement in a real application. Why record and replay movements? In real-world robotics, capturing exact joint movements is essential for automation and repeatability. Here, you'll learn a simple, training by demonstration approach. Move the arm by hand, record the positions, and let the robot replay them later. The controller setup is the same as in Module 9. Joystick 1 controls the base and shoulder. Joystick 2 controls the elbow. Button 1 and Button 2 are used for recording and playback. Refer to Module 9 for detailed wiring and setup instructions. We initialize the ADCs for the joysticks, set up the buttons with pull-up resistors, and configure PWM pins for the servos, just like in the previous module. The functions for converting angles to PWM and for smooth servo movement are also reused from Module 9. If you need a refresher, please watch the relevant section in that video. Here's what's new. When you press either button, the current servo angles are recorded and stored in a list. This allows you to use one hand to move the joystick and the other to record the pose. To play back your recorded sequence, simply hold both buttons at the same time. The robot arm will smoothly move through each recorded pose, just like you demonstrated. Let's pause for a moment to talk about how Python lists work in this project. Each time you record a pose, the servo angles are saved as a group, called a tuple, inside a list named recorded_steps. Think of a list as a container that can hold many items. In our case, every time you press a button to record, a new set of angles is added to the list. When you want to play back, the program goes through each item in the list, moving the servos to those exact positions in order. This is a powerful and flexible way to store and replay sequences in robotics and programming. Power on your controller, move the servos with the joysticks, and press the buttons to record each pose. When you're ready, press both buttons to watch your robotic arm replay the entire sequence. In this module, you learned how to control 3 servos with joysticks, record and play back arm movements using button combinations, and create a user-friendly recording and playback system. This is the foundation for more advanced features like gesture learning, motion sequencing, or even robotic choreography. Don't forget, the 3D printed controller enclosure you see here was designed by Tokyo_bird on Thingiverse. Visit www.botronixlabs.com to download the STL files and give your project a professional finish. Congratulations! You've just completed the entire Botronix Labs robot arm project. From wiring up your first servo to recording and replaying complex movements, you've built a real, multi-jointed robotic arm and learned essential robotics and coding skills along the way. But this is just the beginning. We have even more exciting, intermediate-level robotics courses coming soon, covering advanced programming, sensors, automation, and much more. If you enjoyed this series and want to keep building your robotics skills, make sure to subscribe to our channel and turn on notifications so you don't miss any new content. Thank you for learning and building with us at Botronix Labs. We can't wait to see what you create next.